Okay, example 7. If a 24-inch diameter flywheel rotates to an angle of 140 degrees in 1.1 seconds, what is the average angular speed of the flywheel in radians per second? All right, so average angular speed. Okay, angular speed involves a circular distance traveled per unit of time. And typically, the 24-inch diameter flywheel, that's not helpful information here. If we want to know the actual distance something traveled on the edge of the flywheel, that would matter. If we want to know the speed of a, let's say it's a car with its wheels turning at some speed, we want to know how fast its car's traveling based on the speed of the tires rotation, then the radius of the wheel would matter. But if I'm just trying to find an average angular speed, let me just start off by typically in trigonometry we use the letter omega to represent angular speed. I didn't invent that, that's just what people tend to use. I'm going to use what people tend to use because it'll probably show up in the book. So usually if they're talking about angular speed, it's typically referred to as omega. And to draw an omega, it kind of looks like a W, but you start here, you come, make a little loop, and then you come back around. That's how you make an omega. So, anyway. The average angular speed equals the number of degrees, rotations, or revolutions, let's go revolutions, or radians over total time. So the top number is either going to be degrees, radians, or revolutions, and the bottom numbers will be how long it took. And they should feed you that information. And just like the average linear speed, you're going to get a unit on your answer that may or may not match the unit they're looking for. We might have to do some unit conversion to make the unit they're looking for. So we start off with what we're trying to find just to get an answer. Okay? So basically, first step in both of these problems is figure out what the answer is. Step 2, convert to the proper units. So it rotates through a 140 degree angle, that's the top number, and it took 1.1 seconds, that's the bottom number. So our omega in this problem is going to be 140 degrees. And again, I'm looking at possibly doing unit conversions. I'm not going to write the degrees, so I'm going to write DEG over 1.1 second. Now, if I punch 140 divided by 1.1 on my calculator, you'll see it doesn't divide evenly. Okay? So because it doesn't divide evenly, I'd rather just leave it as is while I'm doing my unit conversion, and I'm going to round my final answer. It'll be more accurate. So the unit I want is radians per second. The unit I have is degrees per second. Does anybody recall the relationship between radians and degrees that we saw yesterday?
Isn't it like pi?
Pi. 180. And what? Pi what? 180 what?
Depends if you're
180 is degree and pi.
180 is definitely degrees, and pi is definitely radians. It depends on where we put it, Ashton, but pi is always radians, 180 is always degrees. So those are the facts. So 180 degrees and pi radians are equivalent values. And what Ash was getting to is where we put things over here matters where things are, right? So in this case, I want to convert from degrees to radians. Currently degrees is living in the numerator, so I need to put degrees in the denominator. I want to change to radians, so I'm going to put radians in the other position. We have pi radians is the same as 180 degrees. Degree cancels degree. The units left over, radians on top, seconds on bottom, which is radians per second, which is what we're looking for. So there's everything we need to know. I'm going to do this 140 times pi divided by 1.1 and divided by 180. So again, here's the situation where I have multiple things on the bottom. Watch how I type this in. Bring it over here out of the way. 140 times pi. I'm going to do divided by 1.1 and divided by 180. Make sure that every number on the bottom is being divided, not, again, it's tempting to put divided by 1.1 times 180, but again, divided by 1.1 says, hey, calculator, that's on the bottom. Divided by 180, hey, that's also on the bottom. Tell the calculator where it is when you're typing it in. hit equals, and we get 2.22 radians per second. Just a quick hint, one full time around the circle is 2 pi, which is about 6.28 radians. So 2.22, if you triple that, that's 6.66. So it goes about a third of the way every second. So you're looking at this wheel, about every second, a third of the way is going to turn around. So again, the diameter does not come into play in this problem because it's not asking how fast, this, like if there was some sort of a tire or something on a vehicle making it go. So the diameter would matter there. All we're looking for is how quickly this wheel's spinning around. And 2.22 radians per second is the answer.